Good day, my beautiful greetings. Today is a beautiful day to be learning about period and frequency of what the transverse wave. Yes, first and foremost, they like to indicate what is a period because many people have been struggling with this chapter for a long time. A period is simple, it's a simple topic. A period is what it is the time, keep in mind, is the time for one complete wave to pass a point. And the time is what is measured in what? In seconds. So the time that is measured to what? It is measured toward what? Toward the completion of a wave passing a certain point. Yes. So that's just the time for one complete wave to pass a point. I don't know if you understand me. Hopefully that it grabs it. I don't want to make things more complicated. So let's just have this diagram here with us to make things more simple and more understandable. Yes. So first and foremost, I would like to show you that when you talk about what you call a period is just firstly, you must understand what you call a wavelength, and you must so that you can get the grasp of what in phase and out of phase points that are in phase and the points that are out of phase. Yes, I have a video on that in the playlist. Go and check it out so that you can solidify your information on the period. So here we have a crest. Yes, here we have a crest because it's just the top of what of a wave. Here we have a crest. So the distance between these two crests will give you about what the period. Yes, because of this crest, it is what it takes a full complete what wave. It results in what in a full complete wave. Yes. So yes, as I was saying, these 2 points, these two crests will form what a full wave, as they have said in the definition. It is what there is the time for one complete wave. Yes, so the time of what over one complete wave. This is a one complete wave, my dear returns. Yes, so this will give about what it will give about what the period, and it's measured in what measured in seconds. Yes, give about what the period measured in seconds. I'm so sorry, I don't have my pen today. The writing is a bit wiggly. Okay, so we're going to move on to a more clear diagram so that I can understand what is a period more clearly, maybe with numbers. I couldn't have gotten time to make a more clear diagram. Please don't come for me, my dear great sons. Okay, so here let me put some numbers. Here we can say 0. Here we can say is 5. Here we can put what 10. Put what 15. Put what 20. And I'm struggling here, my dear good sense. Here we can put 15. Here we can put 20. Here we can put 25. And here you can put 30. Yes. So I want you to get something. If only the wave starts here, it goes onto the top of the crest and goes down to the trough and ends here by 10. The wave length of it is what? It is from this crest to this crest. But then the period will be determined from what? From where the wave started and to where the wave ended. Yes. So from this point, let me find a different color. So from this point here, from 0 to what? To 10 is going to be what your period. So meaning that your period is going to be 10 for this wave. Yes, hopefully that is clearly understood. So another one that may pop up in exams, but I do not have to worry much about showing much more examples because there are practice questions that are coming through going to be more solidified with information from them. Yes, so I think we must just through this chapter of period. Just understand that period is just what it is, just this time or this time interval between what a complete wave. Yes. So going to what we call a frequency. What is a frequency? Frequency is the number of complete wave cycles that occur in 1 second. So that's what is the number of waves that occur in 1 second. Yes. If I can ask you, what is in your own mind? What do you think has the highest? What wave do you think has the highest frequency here? Obviously, this one is written as what highest frequency wave. There is a reason for that, because what, there are many waves within 1 second. Yes, as you can see here, there are many waves. You can see one, you can see two, you can see three, four, five, six. There were six waves. Oh, there were six waves. There is wave cycle. But then let's come to this one. Same thing, same diagram, but then different what frequencies. There's one, two, three. So yes, the frequencies are what? The frequency is different. Yes. And keep in mind, the shorter the wavelength, the longer the period. The longer the shorter the frequency, the longer the period. The longer the frequency, the shorter the period. Yes, just vice versa. Yes, they are what? Directly proportional. Frequency and period are directly proportional. So I'd like to quickly go into what the relationship between period and frequency. So period and frequency are reciprocals of each other. So whether in a question they might ask you and say to you, find the period of a certain wave pattern. But then if they have given you the frequency in that question, you can quickly just say what? You can quickly just pull up this what what do we call it again? Oh, my mind is slipping me right now. You can quickly call out this equation. Yes, f equals to 1 over t, or t equals to 1 over f. So if only you have the period in the question, you can just say what? F equals to 1 over period, but to get the frequency. Vice versa, if you have the frequency, you can just say what? Frequency equals to 1. Frequency just can say period equals to 1 over frequency. Yes. For example, they have given me 2 hertz of frequency and the one in the period. Excuse me for my writing. They've given me two hertz and they want what? They want what? The period. So I'm just going to say 1 over 2 and simply just, that is what? 0.5. And simply I found my what? My second, 0.5 seconds. Add that little s there. Then you're done with the question. Yes. So that's how they help you in exams. And I thank you, my dear Gretens. Hopefully you have a great day.